AP. Today we're going to look at section 2.4 in your textbook, and the title is the chain rule. And this concept is very, very important to your understanding of derivatives in calculus. We have two learning targets. Number one, I can find the derivative of a composite function using the chain rule. Composite function from Algebra 2 means that there will be two functions in one. So think of composition like f of g of x. Number two, I can find the derivative of trig functions using the chain rule. So the entire section and all the examples that we do in the next set or two of notes are dealing with the same idea. There'll be multiple functions involved in your problem, and we're going to learn how to derive each piece. Chain rule deals with a composite function or combination of two or more problems. And I want to go over like a quick algebra review. So I made reference to this a second ago, but when you have like, let's say the f function is just a parent graph, like square root of x, and the g function is a linear function, 3x minus 5. When we compose or find the composition of f of g of x, we're basically, just recall from the past, always starting with the inside. You're going to your rule, which is 3x minus 5 for the g function. You're substituting what it's equal to in the parentheses, and now the problem says or states, find f of 3x minus 5. Well, that means go to your f function, and where you see x, replace it with 3x minus 5. And so, I'm going to write this over. The entire composition then would be the square root of 3x minus 5. Okay, so f of g of x. Also recall from Algebra 2 that there was another notation we used. Sometimes the ACT does this as well. So when you see that notation with a little, it's almost like a degree symbol, that also means compose or composition. Okay. Alright, Theorem 210 in your textbook is dealing with the chain rule, and it basically says this: if y is equal to f of x, so we're dealing with some kind of function, if that function is differentiable of u, and so introducing the letter u here, u is going to stand for the g of x function, which is the inside piece. So if y is equal to f of x, and that's a differentiable function of u, and u is equal to g of x, and it's a differentiable function of x, then that means the composition of those, f of g of x, is also differentiable. And so basically, if I can find the derivative of f, and I can find the derivative of g, then it makes sense that when I compose them and put them together, I should be able to find the derivative of that composition. Here's the notation your textbook uses. dy dx, find the derivative of y with respect to x, and here's how you do that. You first find the derivative of y with respect to the u. Again, remember u stands for the g, or the inside function, the g of x. You're going to multiply that by du dx. To find the derivative of y with respect to x, you're going to first pay attention to the outside function dy du, and then multiply that by the derivative of the inside function du dx. This notation at the beginning, since it's the first time you're seeing it, may look confusing, but once we go through some problems, you'll understand the notation a little bit better. Here's another way to write it. d dx, find the derivative with respect to x of f of g of x. You're basically going to take the derivative of the outside function, which is the f. Notice my prime mark. You're going to copy down the inside rule. Please notice that says g of x. You're then going to multiply that by the derivative of the inside rule. derivative of outside function times derivative of the inside function. Derivative of outside function times derivative of the inside. And a quick note, very important, don't change the inside function while you're trying to find the derivative of the outside. Never change the inside function. This will stay exactly the same as the original problem while you're deriving the outside. Also, never do more than one derivative at a time. So, always derive the outside function, copy the inside function down, multiply that then by the inside function's derivative. Example 1. Find the derivative of the following function. We have f of x equals 2 divided by 3x plus 1. Now, what I want us to do is kind of tie this problem into our last unit on our last section on quotient rule. So what we're going to do right now for the first part of this problem is we're going to backtrack and just quickly try to find this using the quotient rule. And so I do see a division bar, obviously. The rule for the quotient rule for finding a derivative is going to be a quotient. Remember from the last section, I always go to the bottom, the denominator first, and I square it. And then on top, you're going to take the derivative of the top. So the derivative of 2 is 0. I'm going to write that down. You're supposed to multiply that by the denominator, by the bottom. Then the quotient rule says subtraction in the middle. Got my little brackets here. You're going to copy down the top for the numerator, and you're going to multiply that by the derivative of the denominator. So the derivative of 3x is 3. The derivative of this, like positive 1, is 0. So this will just be 3. Derivative of top times bottom minus top times derivative of bottom divided by bottom squared. Now it's time to simplify. Numerator, 0 times anything is 0. 2 times 3 is 6. So on top we're left with 0 minus 6. On the bottom I have 3x plus 1, quantity squared. And so the derivative of the f function is negative 6 over or divided by 3x plus 1 quantity squared. So this is my answer. Okay, now we're going to take the exact same problem and we are going to apply the chain rule to it. But in order to do so, you really do have to see this, it's a fraction to begin with, but we're going to rewrite this problem so there's no fraction. And in order to do that, you're just going to use algebra skills. So this denominator, when I move it to the top, the power on all of it changes. And so 2 divided by 3x plus 1 is the same as 2 times 3x plus 1 in parentheses raised to the negative first. Okay, so when you're looking at, this is just a different way to see it, you can rewrite it using the negative power, and then break this down as we need to, starting now, be able to look at a problem and see the outside function. I'm calling the f function the outside function. The g function is going to be the inside function. And we need to be able to look at any type of problem they throw at us and be able to identify. So remember, this is based on composition, f of g of x. You have to look at a problem and see two problems in one. So to get started, if f of x is equal to 2 times this raised to the negative first power, then the outside function is 2 times something, and I'm just going to use x for this problem. I'm not going to write all of that, to the negative first. So that's the outside function. The inside piece is going to be this binomial, and so that's what's going to be the g rule, 3x plus 1, because that's the inside function. Okay, and then if you're not sure where I am right now and you're wondering where I got that, now go backwards. If this had been given to you up front, and this was the f function and this was the g function, and I ask you to write down f of g of x, then I would ask you to take 3x plus 1, put it in the parentheses here, then go to your f function and put 3x plus 1 in place of x. If you can visualize that right now in your head, you're seeing 2 parentheses 3x plus 1 raised to the negative first power, and that's exactly what I have here. So when I give you a problem, the first task, and we're just going to have to practice this, get used to patterns, you're looking for the outside function first. We're going to call that the f function. We're looking for the inside function second, which is the g of x function. Air textbook sometimes calls it the u. I'm going to drop that down here too, because there's different ways to see this. But the g of x, or the u, is 3x plus 1. Now, according to the chain rule, your job is to find the derivative of the outside function first, and then copy down the inside rule, then multiply it by the derivative of the g function. So, let's put that into action right now. We're finding f prime x. The derivative of f is, first we're going to do the derivative of this. The derivative of f of x, let me put this underneath, over to the side, it's just a simple power rule. Negative 1 times 2 is negative 2. X to the, and then you're going to drop the power by 1. So negative 1 minus 1 is negative 2. Okay, over here, we're going to apply that to the outside function. So negative 1 times 2 is negative 2. You're going to copy down the inside function right now. You're not going to bother it. Remember, we are deriving the outside. You're going to drop the power by 1. You're then going to multiply this by the inside function, which is over here. And the inside function, g of x, or the u, is the derivative of that is going to be 3, looks like. So we're going to take the derivative of this inside piece, which is 3, and write it at the end of the problem. And then next, what you always want to do when you're trying to use the chain rule is simplify as much as you can, as always. So we have a negative 2 and a 3 here that need to be multiplied together. And then you also could actually take that negative power and relocate it. And so negative 6 would stay on top because it's raised to the first power, and the binomial would go to the bottom. As a positive 2 power. And then you can compare your answers, whether you thought about this problem using a quotient rule or using the chain rule, you can see that they give you the same result. Okay, let's try number 2. Example 2, I have f of x is equal to x plus 2 quantity cubed. So over the side, the textbook's going to ask you to do this as well. You're going to have to write down the outside function and the inside function. And I don't want this to confuse you, so I'm going to change this to the letter H. Okay, sometimes they use the same letter here, and then I'm using F to stand for outside, so just try not to let that confuse you. So we'll call this the H function. It's x plus 2 quantity cubed. This is a composition problem. There are two things currently going on right now. This is being cubed, and then the inside is not just x, but x plus 2. So the outside is going to be something cubed. And the inside is what's inside these parentheses. That's the g function, and that's x plus 2. Okay, and again, remember our textbook sometimes uses the u to stand for the inside function. If we are trying to find the derivative of h of x, this is a chain rule problem because there's two functions going on. We first find the derivative of f. So to find the derivative of f over here, you would do 3 times 1 and then drop the power by 1. Well, we're going to apply that to this problem. So it's going to be 3 times 1 is 3. Please remember again, I continue to repeat this, but it's very important. Never bother the g function on your first step. You're going to rewrite it. Drop it down. 3 times 1 is 3. Drop this down and then decrease the power by 1. Okay, so that should be a 2 there. You're then going to multiply that by the inside rule's derivative. So the derivative of g of x, or u prime, would be the derivative of x is 1, and the derivative of positive 2 is 0. So you would just say, okay, it's 1. And then I would not leave 3 times 1 left, or in that problem. I'll go ahead and just multiply them together. And that's when you can call it quits. You don't have to FOIL that. So this is a good answer for the derivative of h. Okay, and then just kind of giving you another way to think about this, because often in calculus there's more than one way to find the answer, just like in algebra. This method is probably the fastest, but I have had some students, especially at the beginning of learning the chain rule, where they are more algebra minded and they see the problem like this. If that happens to be you and you're thinking that, then you would probably want to use the product rule. And if you're using the product rule from the last section, you know to find the derivative of the first. This piece would just be 1, and multiply it by the other functions. Okay, then you would go to the middle and say, okay, what's the derivative of this? Well, it's 1, and then copy down the other functions. Getting the same thing. And then next, remember product always has a big plus sign in between. And then you would find the derivative of this binomial, which is 1, and you'd multiply that also by the other functions, which is the same thing again. Okay, interesting. So I have one of these here. I have two x plus 2's, and I have 1 as the coefficient. The same thing's going to happen here, and the same thing's going to happen here. Just make it faster that way. So I have a total of 1 and 1 and 1, meaning I have 3 of those left. And you can see it's the same as the answer above. It took me a little longer to do this, so that's why chain rule I think is definitely important to know, but because sometimes you have to use chain rule, you can't get away from it. But even when given an option, I like to use the chain rule because for me it's faster. All right, let's try this one. We're looking for the derivative of y. Right now I see something to the 5th power. My f of x is the notation I'm using in this section to stand for outside rule. So something is raised to the 5th power. My g function is the notation I'm using to stand for the inside rule, and that's going to be, again, what's inside these parentheses. So come over here, and I find the derivative of the outside rule first. So over here it would be 5 times 1 is 5, x to the 5th. Drop this over to the side again so you can see where I'm getting it from. If the problem had been x to the 5th, the derivative would be 5x to the 4th. If the inside rule g functions x to the 4th minus 6, and we want to find the derivative of just that piece, it's pretty simple. You just say, again, 4 times 1, drop your letter down, drop the power by 1. And then we know the derivative of a constant is 0. This is all you need to find the composition now. Outside derivative first, so 5 times 1 is 5. And instead of writing down x to the 4th, we're going to write down what's in the problem. Again, for the 3rd, 4th, 5th time today, always rewrite this, never change it. After you do the outside function's derivative, then you're going to go to the inside, which is the g function. You're going to derive x to the 4th minus 6, which is 4x to the 3rd. And then last, put those together when you can. Everything's being multiplied together anyway, so 5 times 4x to the 3rd is 20. X to the 3rd. Okay, and then there's 4 of these binomials. And I'm just going to choose not to simplify that part. In other words, I don't want to write this out 4 times and have to FOIL that twice. So I am going to stop here. And you can too, that's fine. Okay, let's try number 4. Number 4, we're going to call that h of x. We have a trig function this time, sine of 2x. The outside rule. The outer rule is sine of something. So we're going to just say the basic one, sine of x. So the inside piece, which is what would have to have been substituted in place of x to get it to be composed. This is a composition or composite function. I had trouble with that. Composite function, there we go. That would be 2x. I'm looking for the derivative of h. Using the chain rule, I find the derivative of the outside function first. So the derivative of sine x is cosine x. The derivative of sine 2x is going to be similar. It's going to be cosine. And you drop that down. Okay, then you're going to multiply that by the inside. Here's the inside piece. The derivative of 2x is just 2. And then let's do a little bit of rewriting here to make it look better. We never leave coefficients at the end anyway, so I'm going to say 1 times 2 is 2. And that's cosine of 2x. So that is my answer. Okay, number 5. On this one, let me change this to h again. On this composed function h, two things are going on. You should see a square root function, and then you should see a trinomial underneath. The outside function is the square root of something. We're going to call it x to keep it simple. The inside function, the g of x or the u, the inside function is what's underneath the radical. Here we go. To find the derivative, let's try the chain rule again. We go to the outside rule first. Now, what's interesting about this one is it is in the square root mode, but we know how to change it to make this derivative easier by calling it x to the 1/2. Square root and x to the 1/2 is the same problem. This is so much easier to derive right now. You're going to take 1/2 times 1, get a 1/2 here. You're going to drop down the actual function, and so that's going to be this piece. Then you're going to subtract 1 from 1/2. So 1/2 minus 1 is a negative 1/2. Then you're supposed to, after you derive the outside, I think we're finished there. Again, notice I just copied this down. Then you're going to derive the inside rule. So now your eyes are focused on this. The derivative of 3x the second is 6x. The derivative of a negative x is just negative 1. And the derivative of 1 is 0. Now, since this derivative of the g function is more than one term, please remember to put all of that in parentheses. And then we are ready to simplify. I would take this piece, raised to the negative 1/2 power, to the bottom and rewrite it. There we go, takes care of that. This fraction in front, we can actually just leave the 1 on top and the 2 on the bottom, and that works really nicely. So anytime you have a fraction as a coefficient and you know part of the problem or part of the answer goes to the bottom, always write it like this. And then the 6x minus 1 is a binomial that is raised to a positive power, so it's going to stay where it is. It's not going to change locations. And then we could actually take out the 1. 1 times 6x minus 1 is still the same. And so what you're currently looking at is the best way to write the derivative answer. Okay, keep going. We'll do a few more here. Alright, let's see. Number 6. Just kind of getting used to the idea. Change this to h again. I've got my h function, tangent squared x. This is a composition problem, so there's two things going on. We just have to be able to kind of study the problem and see it. There's a pattern here. There's a power of 2 on a trig function. We learned from pre-cal that you actually can write it either way. You can say tangent squared x, or you can call it tangent x quantity squared. And I think this way is easier for most people to see the chain rule. The outside piece. The outside function is something squared. So we're going to write x squared to the side. The inside function I've underlined, and that's just going to be the trig function tangent x. To find the derivative of h, we do the same thing we've done in all the other examples today. You're focused on the outside function. The derivative of something squared is just like 2 times the x. In this problem, similar thing, 2 times 1, 2. Drop the inside down. And make the power go to 1. 2 minus 1 is 1. Then, technically, you're supposed to then take the derivative, going to multiply this, by the derivative of this piece. And so the derivative of a tangent x, is, thinking back to the last section, secant squared x. Okay, and so I've done my chain rule, taken the derivative of the inside piece. I don't see any other step that I can do to make this more simplified. So I'm going to stop here. Alright. Okay. Keep it going here. Here's my new, number 7, my new functions h of x. I've got the cube root of x squared minus 1 quantity squared. When I see square roots, cube roots, any type of radical, my first thought is always to rewrite it as a fraction power. So I'm going to do that here. Power on the binomial is 2, and the index is 3. So recall from the past, you take the power, it becomes the top number of the fraction, and the index number becomes the denominator. Just kind of look at that for a second and see if you can see outside rule and inside rule. Outside rule is something to the 2/3. And that definitely, we can find a derivative for that, for sure. Inside rule is that piece. So the u here is x squared minus 1. h prime x, derivative of h can be found by starting here with the outside rule, 2/3 times 1, dropping this down, taking the power and decreasing by 1. 2/3 minus 1. 2/3 minus 1 is 2/3 minus 3/3. That becomes negative 1/3. Multiplied by the derivative of the inside piece. Derivative of x squared is 2x. Derivative of negative 1 is 0. I see a negative exponent again. I've done this once today. Anytime you have a negative exponent, go ahead and move it. Relocate to the bottom. Make the power positive. We multiply 2/3 times 4x. Put this over to the side quickly. 2/3 times 2x. 2x is over 1 if you want to make it a fraction. You can just go straight across in your head. 2 times 2x is 4x. And 3 times 1 is 3. So we could put like the 4x here. That's what I would do. And then I'd put the 3 right underneath the big division bar. Don't write 4/3 up here and then have a fraction with a fraction. Remember, that is not simplified. So this is a great way to write the answer. Okay, so we have more examples. 1, 2, 3, 4, 5, 6, 7, 8. I think we're going to pause here for today's notes though, and then we'll do the rest of them in the next part. So make sure that you, for these examples, I've only done one trig with you today, but your goal is to kind of get your minds thinking along the same lines, that every problem you're given, a lot of problems you're given are really compositions, and you have to select like what's the outside and inside piece, and then make sure that you read the section in this language that you understand.